So here we are proving that the area of a triangle with base length b and height h is a equals 1/2 base times height. So as I analyze the structure of that formula, area equals 1/2 base times height, it occurs to me that the area of a triangle must be the same as the area of a rectangle that has half of the base length of the triangle but the same height, or half the height of the triangle but the same base. So I'm keeping that idea in the back of my mind as I think about how I could prove that the area of a triangle is 1/2 base times height. So we start with an arbitrary triangle, and as I'm weighing my options, I can either take half of the height or half of the base. I'm going to elect to take half of the height, and here's why. Because I know that the mid-segment of a triangle basically will give me half of the height, and it also has some other interesting properties that may come into play and help me to do this proof. So I'm going to construct the mid-segment of the triangle, okay, which is there. And now that I've done that, I can kind of start to visualize where the rectangle is going to be. And by the rectangle, I mean the rectangle that has half the height of the original triangle and the same base as the original triangle. Okay, so the question is, how do I get this region here, this triangle region here, to be over here and over here? All right. Well, something tells me I can do some rotation, and I need to rotate some 90-degree corners over here. So let's do this. Let's take a perpendicular to this segment that goes through this point. Okay, now I only want that segment to go from here to here, so let's put a point at the intersection of the perpendicular line and the mid-segment. Now that I've done that, we can hide the perpendicular line. Okay, so as I said, I'm going to want to take this region here, and I'll go ahead and define the region. And let's give it a cooler color than gray. Green's nice. Okay, so I'm going to try to take this green region here and rotate it around this point, and hopefully it'll make a nice corner to the rectangle that I'm building. Okay, so here we go with that. Okay, I'll mark this as my center of rotation. Then I'm going to rotate it. And from the looks of things, I think I want to rotate it 180 degrees. Okay, so we'll go ahead and do that rotation. Okay, and that looks like it worked out pretty nicely, as I have a nice 90-degree angle right there. Okay, in the same way, I want to take this region here, which I'll define first. Okay. And let's give that a brighter color. Okay, so I'm going to take that region and in the same way hopefully rotate it around to create the corner of a rectangle here. And once again, I know that this is a right angle that I'm rotating because after all, we made the segment perpendicular to the mid-segment. Okay, so let's go ahead and rotate that portion there. And again, that'll be a 180-degree rotation. The sign doesn't matter since 180 is the same either way you go. Okay, and again, so I know from the way I constructed this thing that this will be a nice right angle right here also. Okay, so let's analyze this situation. So I've definitely made a rectangle, as you can see. It's color coded to show you the areas that are congruent to each other, because after all, rotations are isometries, which means they preserve angle and length and keep things congruent. So now the only thing to say is, what is the area of this this rectangle? So let's see if we can write that out in kind of narrative form. Okay, so what I know is that the area of the triangle equals the area of the rectangle. And I know that the area of the rectangle equals length times width, which I know in this case is equal to the original base of the triangle and I know the width of the rectangle. Actually, why don't we put this in parentheses? Okay, I know that the width of the triangle is half the height. The width of the rectangle, I'm sorry, is half the height of the triangle. Okay. So in other words, area of the triangle equals, and let's have some symbols here, equals 1/2 the height of the triangle times the base of the triangle, which is the same thing as 1/2 base times height. And voila, there we are. So we've proven in this situation that the area of a triangle is the same as the area of a rectangle with half of its original height, but having the same base as the original triangle. So the formula is actually true, as we knew it was. And if we want to see if this is true under other conditions, we can drag this around and show that. Okay, so we can show that it's also true, no matter what, you get that nice relationship.